All right, welcome everyone. This is the October 2024 Rust meetup. So if you're in the right room, that's awesome. We have the C++ meetup just over there in another room. So if you happen to be here for the C++ meetup, just wanted you to know that. So my name's Brad, and I lead the Rust meetup group. We are now at 1,797 members, according to meetup.com. So we're just a few shy of 1,800. So, we're seeing a small representation of our, of our group. We meet here at Microsoft's facilities, but we're here under two codes of conduct. First code of conduct is, of course, we are guests at Microsoft, and you can see the code of conduct displayed here, and we're also operate under the Rust code of conduct. In a nutshell, and for those of you who were here, most months, you hear me repeat this, but in a nutshell, it's a request to be respectful to one another. If you feel someone hasn't or isn't interacting with you in a respectful way, step one, please let them know. And if the behavior doesn't stop, step two, please let me know, and I will step in. So introductions. I'd like to introduce myself to kick things off and help keep the meeting to be interactive. My name is Brad Gibson. You'll see me online in any technical online forum as U007D, pronounced Curly. And I started tech back in the 80s with a Commodore 64. I have a Bachelor of Science in Computer Science, started in BASIC, 6502, 6510 assembly language. If there's any Ben Eater fans out there, that guy's like my hero. I think he's awesome. If you don't know what I'm talking about, no worries. And what I like to do is has historically and traditionally been fairly close to the machine, fairly close to the metal. I have found that without really realizing that was even a thing. I just enjoyed that. So today I serve as a CTO at a startup, and I'm not as close to the metal as I might like to be, but it's still kind of fun. So what we also like to do is have other folks introduce themselves as well. This is not just me talking. So if you would like to introduce yourself, first of all, by show of hands, for whom this is the first meeting? Yeah. So maybe a third. Welcome. All right. So yeah, would anyone like to introduce them? First timers, old timers, it's all good. Yeah. Yeah, that's the trick.
Hey guys, my name is Jordan. I'm being a software developer for almost 10 years. I originally started as a game developer on Unity Engine, so most of it is just about C++ or C# in this case. But I gradually grow into it's not working. Oh. Sorry, online community. All right.
It is working. I'm sorry. Okay, either one. Sorry.
It's really hard to tell if this is working or not.
Yeah, I couldn't tell.
Okay, cool. So I gradually started to get into Rust this year and starting to get understanding about the higher level and the lower level assembly languages. So I am more influenced about trying to get myself familiar with the Rust language. The other cool thing about me is I actually hearing impaired. I was born deaf and I have a cochlear implant on my side, so I can actually start here. Without that, I wouldn't be able to hear anything. All right, I guess who's next?
Yeah.
Hi, I'm T. This is my first time to a Rust meetup. I actually, shameful confession here, I got through the hello world doing Rust and then got sidetracked. So Wes has dragged me out here and is like, you need to learn this language. So that's why I'm here. I just recently finished my master's in science and cybersecurity engineering. So if anybody's curious about that sort of stuff, I'd be happy to talk your ear off. Besides that, I have just way too many interests and side projects to discuss. So yeah, that's me.
Oh, you raised your hand, Jack. Too late.
I was waving. All right. My name's Jack. You guys have been very generous with letting me get up at the front sometimes, so I think everybody's heard my name too many times. But I've been doing Rust since 1.0 in 2015, so I've been around for a while. I was working at SpaceX until recently, and we got to put some Rust in space, so that was pretty fun. And yeah, I think that's the big stuff. Really love this meetup. It's fun every month.
It's great. Oh, down at the end, Jack.
Hello, my name is Lowell. I'm a student right now. I don't have any sort of job relevant to this field, but I'm finishing up my bachelor's degree in cybersecurity. Just having to go through all my generals, so I'm trying to spend some time on side projects when I have the time. Right now, I'm working on kind of like a database wrapper application for doing device repair ticket management, because that's the industry I work in at the moment, is phone repair. So that's what I'm working on. It's good to meet all of you guys, and I'm hoping to come here more often.
Great. Thank you. All right. So by show of hands, thank you. By show of hands, how many people consider themselves to be Rust beginners? Okay. So we're looking at about, I was like, you should put your hand down. Okay. So we're looking about half the room. So just so that folks, feel comfortable, right? There aren't any dumb questions. Half the room is a beginner. We've had people show up, they've never written a line of Rust, right? So you're saying, oh, I stopped at hello world and I got distracted. Well, we've had people do even less than that and show up. So just know that if you have a question, feel free. There will be a hands-on coding session today. I'm gonna be redoing a talk I did about a year and a half ago about idiomatic error handling in Rust as a live coding exercise, because a lot of folks who are beginners in Rust may have experience in another language, but they're not quite sure what this whole error thing that Rust is all about, how to handle that properly, because they're used to using exceptions. So we can talk about that. We have upcoming meetups. We try to meet the third Thursday of every month, but when there are holidays or other reasons, we'll sometimes adjust. So for November and December of this year, we are moving to the second Thursday. Had to check my fingers. Second Thursday for Thanksgiving and of course for Christmas. Now, we have been running a sub-theme of doing hardware development. And the original experiment back in late 2023 was, should we run three meetings where we're hands-on coding? So not a lecture format, but what I call the hands-on format. And there was strong support saying, yes, let's do that. So we ran 3 or maybe even 4 meetings, because I think one meeting took longer than expected. I hope that's not the... all right. I was going to say, I hope that's not our streaming channel calling me saying they can't hear. We ran 3 or 4 meetings, and then we took a pause because every other meeting we'd alternate between lecture and then hands-on embedded coding in Rust. And the result was that people said that they wanted to continue. So I was like, okay, good news. So what we're going to do for next month's meeting will be a hands-on session. The last time we got together, we made a little game, and the wiring was a lot more complex than I think anybody ever expected, wiring up a 4-panel, 7-segment LED display. So we're gonna ramp the wiring way back. If you have, if you have a little board with a Raspberry Pi on it, it's going to be an LED and a button. But what we're going to do is we're going to hook up the hardware debugger. So for those of you who have not done this before, you are welcome to join, even if you have not done any embedded development in Rust. So I've never done this before, don't let that stop you. If you need to know what hardware you need, this is the list. You need a $6 Raspberry Pi Pico W. That I'm aware that there's a Pico 2 out now in a non-W format for $5. These prices are insane. They're awesome. I looked into it. That is a different chip. Our tooling and the Rust tooling for like debug probes and all of that is not yet supported for the RP2350 microcontroller. If you don't know what I'm talking about, no worries. It's just got a different CPU on it, and our tooling in the Rust ecosystem has to catch up. So if you come here with a Raspberry Pi Pico 2 instead, because it's newer, and I'm sad to say you're probably going to have a difficult time because none of the tooling will work. But $5, right? You know, $6. And I assume because the Raspberry Pi Pico, the W stands for Wi-Fi, and so if you get a Raspberry Pi Pico, it's $4. So there's a $2 difference between the wireless, the Wi-Fi version and the non-Wi-Fi version. So that means the Raspberry Pi Pico 2W should be about $7. And that's one of the that's one I'm holding out for. I think that one looks pretty exciting. We also need a Raspberry Pi debug probe. What this is going to do is it's going to allow you to single step your code just the way you would if you were developing on your own computer, except the code you're running is running on a different CPU. That's crazy. This is the tool you need. I bought 40 of them. They're about $12. And so at break, what I'll do is if you would like to buy one, I'm selling it to you at the same price that you're going to get it at the store, just dividing by the tax and shipping. So you can have it now. You can play with it over the next month if you wish, or you can buy one from Pi Shop or anywhere else you might want to get one. It turns out that this is a Raspberry Pi Pico. So if you happen to have two Raspberry Pi Picos, I know, right? You can get the software that they preload onto this Raspberry Pi Pico, and you'll have the same thing. You will need what's called an SWD single wire or serial wire debug cable. It's a weird tiny little cable that you'll have to have in order to be able to plug in. But other than that, this is just another Pico. So kind of cool. You'll also want an electronic components kit. This will give you a little board that lets you plug in all of the components that you're doing or that we're working with. You can run wires from different from different places to other places, and that's going to allow you to basically to wire up a circuit that we can control in software. And then we'll hook up the debugger so we can single step through that software and see how it all works. The debugger, and this is the one thing that just kills me about Raspberry Pi Pico. We get about 45 views on these videos, after we publish them on YouTube. So on the off chance that the Raspberry Pi Foundation is watching one of our Seattle Rust user group meetings, could you please stop using USB micro B? Please. This is a micro B cable. You'll get one with this, and you will need another one to actually run from your computer to your Pico, the one that you're running. So you need one is going to come with your debug probe, so that one is covered off. But you will need a second micro B to actually go to your Raspberry Pi Pico W. So you'll need two micro B cables. So please remember those, because otherwise it's going to be very hard to debug. And that's really where the bulk of the cost of a $12 board comes from, is the extra connector cables and the little case. It comes in a little plastic case, whereas the Pico W that you'll get is basically coming naked. I should say, one of the things that I forgot to mention, if anybody's going to buy this, is you can get it with headers. And I'm just seeing that right now. So let me take you guys to this link. This is the Pico. This is the Pico board for $6. But unless you're handy with a soldering iron, you probably don't want this one now that I'm seeing it. So Pico W with headers. There's the one we want. But that doesn't have wireless. But you see how it has little legs on it? So that's just pre-soldered by them. That costs an extra $1 to have it done. So we want the Pico WH. Pico WH. Okay, Adafruit has them. Okay, so there they are at the whopping price of $7. So I recommend, unless you wish to do the soldering yourself, purchasing the WH. And so it has Wi-Fi and it has the headers already soldered on. I will change this link for those who are in the slide deck. I don't know how to stop presenting. Isn't that weird? All right, I'll make that change right now because otherwise people will buy the wrong thing. Okay. And it's Adafruit now too. I don't know if they could make this more complicated. Sorry about this. Okay. All right, so I'll leave the price here. It's actually $7 with the headers pre-soldered, but good enough. And if you are at slides.com/U007D, you can pick up this deck and you can get all of these links. Okay, questions? Yep. Yep. Yes, I will actually get that out this week. If not, I might ask for a little bit of help, but it'll be, like I said, just a button and a single LED, so it'll be quite simple. But yeah, we'll put that out ahead of time. Yes, Jordan. So not every version of Raspberry Pi will work, but the steps that we follow will only work explicitly for the Raspberry Pi Pico W. The steps will be different. The tools that we will be using will support Raspberry Pi 1, 2, 3, 4, and 5. They will all work on all of those chips, just not on the Raspberry Pi Pico 2 because that CPU is brand new, and it's pretty awesome actually, but it's brand new and not yet supported with our tooling. Even though the tooling works, the steps we go through will not. Okay. As usual, we get together. We meet at Flatstick Pub at Redmond Town Center, which is, I guess, a couple miles down the road. And so anybody who would like to chat afterward, we gather out front, and some portion of the group will actually move on down to the pub, grab something to eat. All right. Our meetings are published on YouTube each month now. So if you missed a meeting in the past, you're welcome to check it out there. We always would love to have people speak. So we're now booking, we've got some speakers in for December. So if you have a talk you'd like to give, I gave a talk earlier where I was presenting an interesting video that I saw on Rust. And you can give this talk as a domain expert, or if you can think like half of our group are beginners, so you can also give this talk as a beginner. And you can say, I found this video really interesting, but I only understood half of it. And so typically we like to keep it about 15, 18, 20 minutes long. And if we pause for certain parts of the video that you found interesting or you found confusing, there's folks in the audience here who've been doing this for a long time, and we're happy to have interactive conversations to help, raise your level. So if you want to, do a presentation, either from the perspective of, teaching and or learning, and usually both happen when you do it, we're a friendly bunch. You're more than welcome to come on up and talk about whatever is of interest to you. I know there's several interesting projects afoot in the group. So can anyone think of a project that they might be interested in presenting? Doesn't have to be for December, but sometime in the next 6 months or so. Do you think there's something you'd be interested in presenting? Maybe? Okay. So yeah, there's 3 or 4 folks. So the best way to reach me and to follow up on that would be to go to our Discord channel, or our Discord server. Is that our Discord invite? Nope. Oh, it is our Discord invite. So go to this Discord link, you'll join our server, and you can reach out to us. There. I'd be happy to talk with you. We can review your slide deck. We can tailor it. Whatever you want to do, we're happy to chat about it there. So that's the best place to reach us. Okay. So we have 2 talks tonight. We'll start with a beginner talk with Chris, dependency management using Cargo. Actually, Jordan, we had that conversation before about dependency management with Cargo, so this is great. Chris, are you here? Oh, right there, right in front of me. And then we'll take a break, a 15-minute break, where anybody who's interested will hand out the debug probes, and then we'll resume, and I'll do the live coding with idiomatic error handling in Rust. All right, Chris, come on up.
Got the HDMI installed, so hopefully this is really easy.
Oh, is that a framework?
Yeah,
Nice.
I ripped out the USB port and put in an HDMI just for this.
Very nice.
See if it works.
Yeah. For those who are unaware, framework laptops are these super modular laptops designed for the long term, and you can upgrade the motherboard and upgrade the RAM and upgrade the ports, and it's very cool. Yeah. Oh, that's good to hear. All right, so I'm still in our. Okay, so there's a couple things we should do. I think you need to join the. Oh, it's a gigantic link.
Send it to me over Discord.
Yes. Actually, you can join and go to the general discussions Discord channel, because that's where I've already posted it.
Take the HDMI signal, but
Yeah, well,
some days are like that.
I'll work on that while you're joining the teams.
Here to broadcast.
Let me say, don't use audio so you don't get that. And I will get you.
Oh boy.
How do I share mine?
In Teams.
This is my screen in Teams.
I would hit a refresh.
Give it a go. As I said, this is probably my punishment for using Firefox. I don't know. Probably just angry that I'm trying to use Linux and all that. All right. We'll let others know you're waiting. Maybe there's a way to admit me.
Let me just check this here to make sure.
Oh, I see stuff. All right, now I need to go find the button that says share. Let's share operating system settings. And share the full workspace. There's nothing scary. Cool, do we see it? Cool, we are good to go. So after technical difficulties, which we seem to do every time we do this, but it's like printing. It's the hardest part of computer science. I'm Chris. I'm an engineer. I work on a Linux distribution for a living. So dependency management is near and dear to my heart. So we're going to talk about Cargo's dependency management. Don't worry about these numbers. That's just a guide I put in there to make sure that my screen, my font size is wide enough that it doesn't make it super tiny and that it doesn't overflow. That's all that is. So there's dependencies in Rust. Or will be when I figure this out. Okay, enter does it. So what is a dependency? In Rust, we're talking about dependencies, which is a piece of code or a resource which your program requires to function. Libraries. Rust dependencies are called crates, similar to Ruby gems, Python eggs, Node.js packages, Perl modules. You have other languages that you're familiar with. This is going to be very familiar, probably. Crates are managed by a program called Cargo, which is also your Rust build tool. So when you start your Rust program, you're going to type Cargo build, and that'll build your program. We fairly seldom go through Rust C itself. So the syllabus for what I want to talk about, I want to talk about adding crates to your program. I want to talk about semantic versioning, more on that later. Talk about crate features, dependency closures, re-exports, and dependency resolution. This is going to be very surface level, beginner level. There's much more depth you can go into and rabbit hole here. This is really just designed to get you to a point where you have heard of most of these concepts. So if you see a bug, experience an error, you have kind of a vocabulary to begin looking for how to fix this yourself. Oh, I still want to share the full workspace. Goofy machine. So adding a crate. As I said, I work on a Linux distribution, so everything is going to be on the command line for me. This shouldn't be particularly alarming to you. So looks like it needs to go a little bit smaller. There we go. So the first thing we're going to do is we're going to make a new crate. Our programs are going to be stored in crates. It's crates all the way down. We're going to move into our program and we're going to add a library using cargo add. And the library I've chosen to add is called clap. It does command line argument parsing, which is super cool. And it has a bunch of features. And one of the features I really like is called derive. It gives you this derive macro so you can just type out a struct that says, hey, these are my command line arguments.
please parse them into this struct so I can just reason about it and I don't have to ask it questions and deal with option, and very convenient. I really like it. So I add this one a lot. So that's how you would add a dependency. And these dependencies get stored, references to them get stored in a file called cargo.toml, which is this manifest file that describes your Rust program to the build system. So if we look at the cargo toml that we just created and modified, you can see that it has, a package section where it says, oh, this is my program, the thing that we named earlier. It has a version, has an addition that we don't really need to worry about right now, and it has a dependencies section. And the dependency has clap that we just added, and it's at version 4.5.11, and it has a feature enabled called derive, which kind of matches with what we said when we added it. Like, I didn't say the version, but Cargo just looked out on the internet and said, I'll just grab you the latest one. That's probably what you want. So 4.5.11 is actually a very special meaning in that string. So crates are usually versioned with something called semantic versioning, or semver. And semantic versioning is kind of a soft contract. There's nothing enforcing that you obey these rules, which is sometimes a little frustrating. But at the same time, the more you obey them and the more the dependencies you use obey them, the easier it is to reason about when you can upgrade one of your dependencies versus when you have to hold it back versus when you have to expect that you're going to have to change your code in order to take an upgrade. So the first number is called your major version. Your major version changing means that the API has changed in a breaking way. So you probably need to update your program to take the new version. Then the next version, the next number is your minor version. The minor version is for feature additions, which don't break or change the existing APIs. So if you add something and it's totally valid that someone can continue using your crate without changing their existing program, you just added something, minor version bump, cool. That's totally fair. And then the patch version is for bug fixes and security fixes that don't break the API or add in features. If you're maintaining a crate that you're vending to other people through crates.io maybe, this also can be used. I don't know why it keeps asking me that, but we're just going to pretend that's okay. It can also be used for when you update your internal dependencies. So you're vending a crate to someone, and then you say, oh, but I have got all these other dependencies that I use, and I'm going to update them. And whoever's using my crate doesn't really care. So I can just use this minor version bump and say, oh, I updated stuff. Now I can publish a new version, but you don't have to care. It's a harmless update, usually. And then major version 0 is special. Pre 1.0 crates generally use their minor version to indicate API changes. That way they can do a bunch of changes without committing to being, I'm 1.0, I'm stable. Kind of the half-seas mark. So when you see stuff that's 0. something, oftentimes they're super stable and it's totally okay. But sometimes what they're trying to tell you is, I am not going to commit to this long term, so don't hold me to it. So the semver dependency declarations have a very special meaning. Cargo interprets bare versions in dependencies as a caret requirement, which allows any semver compatible upgrade. You remember how we're talking about how certain number changes mean it's API compatible or API breaking? So if I were to say, hey, I want version 1.2.3, that means that I can take 1.2.3 all the way up to 2.0, not including. So there's a bunch of stuff going on there. Like if I said 1.2, that would indicate, oh, I can take 1.2.0 up to not including 2.0. We've got our set expert here to keep me honest. But yeah, so you can see how this kind of you can very tersely express things. So like if somebody added a feature in one of those minor version bumps that now you depend on because you're using it, you can say, hey, I require at least this version. I can take new things, but if you try and go backwards, you're going to break the build. And this is super useful. patch versions as well, just because that's how the semantics work. So for example, if I try and add clap at 4.5.0, it'll actually install 4.5.11 because that's a semver compatible upgrade. And if you're not familiar with that, I'm cargo adding clap at 4.5.0, which is a way to specify the version I want. And then I'm piping standard out to grep to say add clap because I don't want to spam you with a whole bunch of extra stuff. So there are other dependency specification syntaxes, particularly which allow forbidding ranges of versions. So if you had a particular need to say, I will accept only this version. I have a very hard dependency on this particular version. The name right there, that's the only one. I think it's equal sign is version. But there are other syntaxes which you can use to get very specific about this. It's all in the cargo book. So if you go to crates.io, look at the bottom of the page, there's a link called book. And you can go there and it has all of this amazing documentation about cargo and how the build system works. And it has a whole section about specifying dependency versions. And there's a lot of really good stuff in there about the other kinds of dependency versions, specifications you can make to control that more carefully if that's a problem that you've fallen into where you need to get really specific about it. But generally speaking, carrot requirements are just fine. So beginner level. So the next really cool thing is crate features. Rust supports conditional compilations, and cargo tells Rust what to compile using a feature called features. Features enable you to turn off parts of a dependency you might not want because you want a smaller build with a smaller binary size, you just don't care about it, or enable features that you need that are disabled by default because the author decided, hey, this isn't really applicable to most people, so why force it on them? So for example, in my program example, because I enabled the derive feature, I can use the parser macro to build my argument parser. This is a macro that auto-implements a trait called from arg matches, which otherwise I'd have to write myself. So what that allows me to do is like this really simple program here. I can just say, hey, I have this struct A, it derives parser, and then I tell it, hey, this verbose, it's going to have a long flag, a short flag, and its default value is false. And then I can just say, hey, that struct parse it, and then I can use the value of it. So, that's an example of a place where I've used this feature to gain this proc macro, derive macro, that some people might not like because they don't like macros. Totally fair. So you don't have to have one in your build system if you don't want it by just not enabling the feature. So you can disable the default features as well. So you can say, hey, clap, no default features. And then if I go look at my cargo.toml, I will see that it has default features as false. So then if you remember that one of the earlier slides had this big list of features, all those are gone. You just get the bare minimum you need to parse args. So it can make your program smaller by dropping features and behavior you don't care about. There's less stuff in your program, so there's less binary to cart around. Might be important to you, might not care. It's yours to deal with as you want. So the next kind of step in dependency management knowledge is dependency closures. So dependency closure is a tree of dependencies. A single crate has multiple dependency closures. Usually you only have to think about your runtime dependency closure. So there's additional dependency closures for different purposes. They're usually additive to your runtime dependency closure, but not always. So there's dev dependencies. These are present at test time. So if you want a dependency so you can write it in your tests, you can use it in your tests. Like maybe a special crate you found which has a bunch of really cool assertions, so you don't have to write all this assertion code and you can use some shortcuts. You can add that as a dev dependency. And when somebody uses your crate, it will not be present in your crate, but it's there when you try and test it. So that's a super cool thing you can use. There's build dependencies. These are present when you run a build.rs script. So that's a script that runs before your program compiles, and it's written in Rust. So like Rust will compile a program which will emit some stuff which tells it how to compile your program. Don't think about that one too long. But if you want to take dependencies into that script, you know, to like simplify querying local C compilers or whatever, you can add that as a build dependency. And then there's platform dependencies. These are added based on your compilation target, such as if you have a Windows or Mac only library that you need to pull in to deal, you know, maybe with the Windows API, but it's perfectly valid to compile your program on Mac and there's no Windows API there. So you can drop that dependency when you're not compiling for that target. So there's a bunch of cool stuff you can do there, but that's dependency closures. So for an example, if I were making a library to call a remote service, I might include the request crate. I might then also include an HTTP server, such as Axum. I rather like that one myself, as a dev dependency. So I can write my tests for my service client. So I'd, you know, go cargo add request, cargo add dev Axum, and also Tokyo, because Axum is async, and you know how much fun that makes everything. And then you'd look at your cargo toml and you see that in my dependencies, if you were to use this crate, you know, this service client I wrote, you know, maybe it calls GitHub or Google or something. The only things you'd have to worry about would be clap, which I left there by accident, but really you'd only have to worry about request. So that would be the only dependency you're taking into your program. But then I can be opinionated about the runtime, the async runtime I bring, and I can bring an HTTP server, and that's only there for testing. So I can, you know, kind of mock out that thing I'm trying to call and reason about how well my library is working without having to infect your program with all of these dependencies. Yeah, so as I said, the Axum and Tokyo dependencies are not exported to consumers. With me so far? Cool. So re-exports. This is both amazing and will get us into trouble. So any dependency that your library crate takes can be re-exported so that consumers of your crate can use it. So if I, in that previous example, took a dependency on Tokyo and I said, you know, essentially there's no use case where you aren't going to take a dependency on Tokyo, I will just re-export this version of Tokyo so you don't have to add it to your own cargo toml. Don't do that. But the part of the crate you re-export becomes a part of your public API because its symbols are exported with yours. So changes in that dependency affect your own Semver lifecycle. So if I have a, you know, crate like Tokyo that I've taken on, and I take it on at version 1.0, and then it updates to version 2.0, I cannot update that dependency without also updating my own major version if I want to maintain Semver compliance. As I said at the beginning, nobody's checking this. There's no tool that's going to slap your hand if you do it wrong. But you might cause a compile failure for someone who's using your crate and make them a little sad. So just rules and things that you can, yes. What is a practical application? Good question. So you would use this in cases where you're taking on a dependency that you don't want to have. It allows you to take on a dependency that your consumer would have to take on themselves otherwise. So like an example I can think of is if you start doing stuff with databases, you might start using the diesel ORM. And if you try to do things with dates in your database, which is not unheard of, there's a library called Chrono, which is really cool for reasoning about dates relative to time zones and parsing them. There's a lot of cool stuff. And there's effectively no case in which you're going to start dealing with dates in a database without using Chrono. So Diesel will export Chrono for you, so you don't have to go add it to your cargo toml. You can just take their version of Chrono and use it from there. So instead of going, you know, Chrono : I think it's capital UTC, but don't quote me on the API path. You'd go Diesel : Chrono : you know, to get to it. And that way you can take your dependency's opinion about a particular dependency. Yeah. Yeah, that's actually a good example because as I understand Ratatouille, it becomes additive to cross-term. Yes? To read the what? Oh, yeah, I should do that. Um, yeah, so you had a question about another example, which would be Ratatouille, a console TUI library where there's kind of a base library called Crossterm that has a lot of the fundamentals, and Ratatouille builds some nice abstractions on top of it, and so they re-export Crossterm. As I understand it, I haven't played with it too much. It's kind of a way to say, here's some cool abstractions, and if you have to build your own, here's the thing we use to build ours, so you can slot them in right next to ours, and it should all work together really nicely. Yeah, for sure. So Carl's talking about he has a set library dealing with sets, ranges of sets, and he re-exports a multi-dimensional array library because you're just going to have to take that one anyway. So why belabor the point? So yeah, re-exports. So if that multi-dimensional array library had a breaking version bump, and you took that breaking version bump, you'd have to make a version bump of your own to effectively respect Semver, which not everybody does. Don't worry about it too much. So I want to add this all together to my favorite error regarding dependencies. So my coworkers will tell you I'm pretty good with a joke. So, let's make my goodness. I think it's disconnecting and then it's reconnecting and be like, hey, do you want to say, do this again? Just us. Okay. Well, that's cool. So, let's make a little program called jokes, because I know at least one joke. We're going to use vec1, which is a cool crate for expressing a vector with at least one element. It's effectively the same in every way, but if you ask first, it doesn't give you an option. It just gives you the thing, which is kind of trivial, but also really fun at the same time. I think vec1 is great. So I just have this vec1 of jokes, and so I have a joke in there. And so now the rule is any consumer of my jokes is now consuming vec1. So changes to vec1 might potentially break users of my at least one joke. So dependency resolution crates are namespaced under their consumer. So generally, you don't know or really care what crates one of your dependent libraries is using. So two different dependencies using two incompatible versions of the same library are totally okay because they're isolated from each other. Under the hood, however, Cargo is doing a lot of work. It will try to reduce the number of different copies of the same crate you have to compile. It might keep one library at a lower version of its compatible dependency because some other dependency in the tree is declared a maximum compatible version. So it's going to try and unify dependencies to try and reduce the number of things it compiles. Yeah. I thought I saw a hand.
I now have that same property that my version breaks everyone else, like breaks language for the other. And that's the consequence of the sensitive properties of.
Yeah, it is. So the question is, if you have a dependency that you've taken that breaks the Semver rules and makes a breaking change against Semver, and you're re-exporting it, you have now transitively broken Semver. And the answer is yes, you have. In general, I've observed that crate authors are actually really good at this and don't do it very often, but it is something that can happen. There are some tools that can help with this. I forget the name of it. Cargo Semvercheck, thank you, which will try and scan your crate and then try and pull down the latest version from crates.io and scan that and try and apply these rules to make sure you don't hurt anything. It doesn't save you against behavior changes. So if you have the same API signature, but the behavior underneath changes, like instead of returning jokes, I return puns instead, if that's not a compatible change. Like, oops, there's no software I can think of that would protect you against that. So there's always going to be a little bit left on us, but you're absolutely right. We are on the hook for our dependencies as well if we re-export them. I'm told it's literally impossible. Yeah. Is there a set of tests we could write to check for this? I'm a big advocate of writing tests. If you have good test coverage, you'll probably catch a lot of the naughty API breakage in your dependency change. So I guess in practice, this doesn't happen too much. But again, like, how can we ever reach perfect test coverage? That's more of a theoretical computer science question than I can answer. So dependency resolution. So Cargo is doing a lot of work under the hood. So like here's that clap program we were talking about earlier. Cargo tree is a really fun little toy. You can type cargo tree and it'll give you the dependency tree of all of your dependencies. I think this is really cool because it matches how I think of them as a tree. But so you'll notice that we have a few packages that are the same. So like sin depends on quote and clap derive depends on quote. And everybody's depending on proc macro too. And you'll notice that they're all the same version. Cargo's only going to compile quote once. It's not going to do it for each dependency closure. So Cargo is doing some lifting under the hood. And it's really cool because it saves us a bunch of time. So what does this all look like in practice? This is going to build up to my favorite bug. So let's imagine that I'm working on a very large project. Someone told me it's a really good idea to break up a big project into many smaller crates. So I've created a Cargo workspace to manage them. Cargo workspace is a fun little helper. It allows you to create this essentially this workspace where your workspace crates can have dependencies between each other, and you can do some fun things to say, I'm going to declare the version of my dependency once and then just always defer to the workspace's version in the little subcrate. So there's a bunch of fun things about workspaces, but for now, it's just a bunch of crates. So I'm going to create workspace for my program. I'm going to add two libraries called add and mul. Should be fairly clear where this is going. I'm going to build a tiny little calculator. And so I'm going to add my workspace to cargo.toml. So I have some workspace members, which is my program, add and mul. Echoing that out to cargo.toml. Again, I'm a shell script junkie, don't get mad. And then for every crate in that mess, I'm going to add clap at version 3. Don't worry about it. And so then I'm going to go into my program. I'm going to say, hey, my program, I want you to depend on add and mul, which are at these paths. They're in my workspace. I can do that. It's legal. So then if I look at the tree for it, I've trimmed this up a little bit to hide clap's interior dependencies because they're not important right now. But they're there. So I have my program, which depends on clap, and then I have add and mul, which also depend on clap, and they're all the same version. So what I should be able to do is write my program where I just, or no, I'm writing add right now. So add is going to have a little parser. It knows about its left argument and its right hand argument. And then it's going to have a function called run, which just prints out the added when I add the two new integers or floats. Actually, I used floats. Cool. And then I'm going to do much the same thing for mul. It actually looks identical, except for it's spelled mul and there's an asterisk instead of a plus. With me so far? Cool. I tried to use simple examples because the hard part's outside of the code. So now we're going to write main.rs, which is the program which calls both of these. So, this is where I think clap is honestly one of the coolest things. So I have add mul, and I have my clap parser, and I'm going to have this sub command, which could be either an add or a mul. We don't really know how to do both at the same time. I'm not a quantum computer. I don't even know if that's a property of those. So then, the sub command is going to know that I can either add or I can mul. And if I do that, I'm going to delegate it to one of those two. I think it's called command map pattern. Fairly standard. And then to finish it up, I have some args. The args know how to run the sub command. And then main is just going to parse the args and run them to chain it on down to add or mul. And so we can see that it works. We can run my program and it can add 1 and 2 to get 3. It can even add 1 and -2 to get -1. The double dash there is to get it to not interpret -2 as an argument flag. Fun story. Figured that one out the hard way. I can run mul. I can multiply 3 and 3 to get 9. So subtraction is just adding a negative, but what about division? So now I want to change the program. I want to add another subcommand. So if I'm very naive about it, I might say cargo new lib div. I'm going to divide stuff now. I'm going to move into div. I'm going to add clap features derive. I'm going to vomit out much the same thing as we've seen before, just with spelled div and using a slash instead of a plus sign or a asterisk. And then I'm going to go try and build my program by adding, I'm going to go add div to my top level program that knows how to dispatch to these different crates. You can imagine if this was a really big, complicated project, each of these subcommands would have their own complicated dependencies and lots of business logic, and it'd be really scary. And this is a cool way to chop things up so that they don't get too crazy in one spot. So, I can modify things. This probably looks pretty boring, like I just added div, and then I added div to the run match arm so I can command map to it. And then I can run cargo check, and it will say that, hey, div does not implement clap from arg matches. Didn't I just tell you that the whole point of clap's parser derive macro is it implements from arg matches? And you saw me put it up there. Like it had the derive macro on it. So like this code looks like it's correct. There's no reason we can think of that it would be wrong. Anybody want to take a guess? Yeah. Exactly. The version of the derive macro is not the same between the two versions. So if I look at cargo tree, remember how I said I'm adding clap at version 3, don't worry about it. And then I didn't add version 3 on div. So I have different versions of clap. So poor Rust is looking at this saying, well, they're spelled the same, but they're from different versions. So there's no way for me to know that these are compatible pieces of code. So even though they're spelled the same, and the error is very frustrating because it says, hey, these two things that are spelled the same, they're not compatible. They're not the same. Jack. I don't know how to go backwards right now, but it didn't say anything about that. Yeah, so add mul, use clap 3. Yes. Well, there's actually 4 of them right now, right? Yes, we could. Yeah, well, the tree is looking at the dependency part of cargo.toml. So that's why I use the tree, because that way I don't have to show you all 4 cargo tomls. But we can go look at it. So the way to fix it is you change it to, let me out. I want to go home. Yeah, so I believe I still have this code lying around. So let's go look at it with you. Workspaces, is it still around here? CD dep talk. I believe this is it. Oh yeah, here we are. So what did you want to look at? Right, so if I run cargo check. Yeah, so this is the error that I think you were asking about. I think it was Jack was asking about. So it doesn't say anything about crate versions. And then you wanted to look at cargo.toml. We need to look at one in a specific program though, because there's 4 crates here. So if I run go to my program, which is the top level one, and I run cargo tree, this is why I had the abbreviated one in the talk, because it gets kind of wordy. But you can see in mul, we have clap version 3.2. In the top level program, we have clap version 3.2. And in add, we have version 3.2. But then if we look at divide, which we just added because theoretically we came by later and we just, oh, I'm just going to add a dependency because I'm working on this maybe a few months later when a new version of the crate is out, it installed version 4. There are multiple versions in this project. Yeah, so if we did that and then we did 4, you'd see it's over there. So you can see how we have this mismatch. Yeah. Yeah, that's really cool. If you find that later, you should stick it in Discord because that sounds awesome. Brad? 5. I think we're about done unless you want to ask me more. Yeah. Found the Linux nerd. All right. So what am I using for the slide deck? What am I using for command prompt? For the slide deck, I'm using a program called MDP, which is a little C program I found a few years ago. I just write some funky looking markdown and then it turns it into a slide deck so I can punch through it on the command line. And I do this because larger programs scare me. And for the command prompt, this is just using stock standard fish shell with oh my fish, and I forget what oh my fish theme I'm using. Probably something resembling Gentoo. I don't know the answer to that, but as I understand how its resolver works, I don't believe it would, because the interior dependencies of your dependencies don't matter to the resolver because it can hide those. So you shouldn't have to worry about them. It's only when you re-export that we run into fun complications. Yeah. How would I protect them from running into this kind of a bug? Really, there's no way to protect you from this bug. Like, I think the error message could be a little nicer. I don't have an RFC for it though. So, yeah. Beg your pardon? I didn't hear it fully. Yeah, so there's nothing, if you're new to this ecosystem, there's nothing in that error message to hint you off that it's not a code problem, it's a dependency problem. I think that's what you're talking about. I agree. Thank you.
All right. So let's take a 10-minute break. For anyone who is interested in picking up the debugger, I have to do some quick arithmetic, but it'll be $12 plus tax plus shipping divided by the number of items that I bought, and so it'll be probably less than $13. But just come on up during the break, and then we'll figure that out. Mhm. 39.57 tax. Ooh, look at you. Oh, yeah. Yeah. It won't run for what we're going to do next month. But for everything else, yeah. Okay. Yeah, that's true. It didn't go anywhere. Divided by 36. So it's 1360 is what it comes out to.
Pico as well.
Yeah, okay. So, I know where to find you. So, yeah. So I have a Venmo. Do you use Venmo or anything? Yeah.
We also have like Cash App.
Yeah, Venmo. Yeah, Venmo's perfect. I'm U007D on Venmo,
Okay.
so easy to find. Okay.
Skin.
I'm sorry?
Scanner.
Oh, 1 second. Yeah. They've already got. She's fast. All right.
Makes it all difficult because we find ways to make things fast.
Yeah, exactly.
No, it's a 3.3 volt. Yeah, okay.
For me.
Because the Raspberry Pi 4 is really a power hungry.
Yep.
And then, well,
1360, please. Yep.
do not have Cash App for PayPal.
Would you remember to bring 1360 next time for November?
Bring $13.60.
That works. I don't have Zelle.
I should be able to hold you accountable for it.
Yeah, I trust. And it's very important that cost is not a factor. So I should have mentioned this too, for anyone for that cost is not a factor, I'll give them to them for free. I did that with a couple of pies as well. So that's just, we're not going to let that get in the way of people exploring this stuff. So that's great. All right, Matt, enjoy. Yes, yes. Yeah.
Setting a reminder for.
All right. Thank you. Mhm.
I do things like that as catch up to more paid copy.
Okay.
I could text him and see if he's. Do you have any preference for either?
Does he have Venmo?
I'm not sure.
Okay, yeah. So that's the easiest way. Okay. Send this guy. Yeah, thank you. That's great. Say again?
How are we using the Picos with the Wi-Fi? We should like have a web server hosted on the Pico or something.
I have an idea for what to do. I was in Berlin at an Oxide conference. You know, Ferris Systems out of Berlin. I was at an Oxide conference, and before the conference, I was helping out with the embedded workshop there with James. Can't remember his last name.
Months.
Yes, James Muntz. Thank you. And he had a really good little thing set up where he set up a Pi, or it wasn't a Pi, it was a different brand, but he set one up at the beginning of the room, and he had it driving a screen. He had like a VGA attachment to this little, maybe it was a, whatever. And he had the Wi-Fi router like in a connect mode. Now, everybody in the room who was doing it got a number, right? 1, 2, 3, 4. And so when you're writing your code, your number would represent a square that would be shown on the screen.
Yeah.
And he was leading the workshop to turn on the radios, make the Wi-Fi connection, and then you would you'd literally push values into memory at your numbered offset. And everybody started like, first you just turn it green. And so you see a green one for number 5 and you're like, okay, number 5 is in. And so then people started getting fancy and they were drawing like Mickey Mouse and cartoon characters, because you only had like 64 pixels or something like that. So they'd start doing like little Nintendo icons and writing words and stuff like that. And what it allowed is for people who were more familiar, they could go further and get fancier in their pixel space.
Yeah.
And the folks who were sort of beginners were, just getting access was enough. But on these Pi Ws, you have to go over the SPI bus to get to the Wi-Fi chip. Yeah. And then the LED that's on the non-W one that's hanging right off of GPIO is hanging off the GPIO on the Cortex M0 that's inside the Wi-Fi chip. So you're remoting from your machine to a dual-core Cortex M0 to over the SPI bus to another Cortex M0 to that guy's GPIO pin to light the LED. So getting that right was, well, in our case, is tricky, but doing something like that so that people are actually using the radios, because then you're in a situation where you could theoretically turn on Bluetooth or something like that, and you could start to remote control car, and you could have some fun with a toy, right? So yeah, it would be very cool, but I have to have time to sort of first do it myself and then see if I could break that down for the audience in a way that people can digest. But yeah.
It's like really simple.
Mm-hmm.
Do like a multiplayer whiteboard or something.
Yeah, that would be a good one too. Then everybody could draw all over the whiteboard.
Yes. But like
Yeah. I think that'd be very cool. Well, I'll be thinking about that for the new year, something like that, because it's less wiring and more coding. And so we could even start people at different levels. Right? If you're a beginner, take branch number 3, where 80% of it's already been coded up for you, right? But if you're an expert, take the empty branch, start from there. Like there's a lot of ways we could do this. It just takes time to organize it. But I like that idea. I like that idea.
You could directly go people sharing with each other.
Oh yeah. Through the central one or peer to peer? Yeah, yeah.
Everyone like has a username and then they reach out and find each other like over the air.
Yeah.
And you just meet or
Yeah.
like, I don't know. All kinds of chat
Or make a chat. Yeah, make a chat app, right? Yeah. Hi.
For the Raspberry Pi stuff, do you take card or how do we?
Do you have Venmo by any chance?
So man, years ago.
Yeah. I could give you my.
Possibly. Yeah, like it's still installed.
No one is more shocked
I
than
do.
you.
Maybe
Yeah.
I do.
It's $13.60 for the debugger. That includes all the taxes and shipping.
Oh. Hey, there we go.
Okay.
And I send you
Mhm.
13,
Yep.
23.
60. Yeah, 1360.
1360.
Oh, that would be a bit too much. That would be a bit too much. No refunds.
Clever social
I'm
engineering
just
attack
joking.
there.
Yeah, I'm just joking. Of course, I'd refund you. Yeah.
Let's see. How did
I think you might need to put the decimal point in.
really then though? 13.60.
That's weird that that's like a memo field, I think. It's gonna pay zero. I think that's your field.
You 13.60.
Yeah. There you go. Yeah, I thought it would have an implied decimal place too. Yeah.
This is why I don't use this program anymore.
No, that's not the Pi. That's just the debugger.
Okay.
Okay. So there are two other
Are you
things.
selling more?
I don't have any more. For when we started, I had a whole box of stuff.
Okay.
But I don't have any more, and we don't know how many we're gonna get. So
Pick up the remainder for next month.
wherever it went. Here we go. So what you have is the debug probe, which is the second bullet. Okay. You want the first and third bullets, and don't forget that USB cable.
Okay, will do.
Okay, no problem.
And sorry, I got to bounce a little bit earlier.
Yep.
Thank you very much for the meetup.
Oh, you're very welcome. Yeah, anytime.
See you next month.
Yeah, look forward to it. Okay, let's get going, everybody. We've got 40 minutes to get this done. So here we go. We are. Okay, yep. A little louder? Yes, we are. Okay, so the second presentation tonight will be idiomatic error handling in Rust. When we rebooted this group, I did this as, I think, probably our first demo, and if any of you here today were there for that, it went pretty well. People enjoyed it. But now that we are broadcasting and recording these, putting these on YouTube, some folks thought it might be good to do this one over again. And we also have all new folks. So if you are used to other programming languages, you are probably familiar. If you come from the C world, you're used to errors. And what we are going to do today is going to do error handling differently than what you're used to. Errors in C are usually sentinel values. Like -1 means that something went wrong, and a positive value, or 0 might be okay. It's turned out that like null values, who's seen as like a $1 billion mistake. Sentinel values have this similar reputation where it's really hard to get that right all the time, every time. So Rust takes an approach from functional languages that says we're going to take these error values, but they're not going to have any special meanings, and you're going to be dealing with the type system in order to get this right. And so we're going to be talking about the type system and values today, and that's what's going to be materially different from how errors are handled in, say, a language like C. For most other people in the room, you're probably used to using exceptions. And one of the big changes for people who are used to using exceptions, when they come to Rust, they want the try except, they want the wrapper, they want like just throw and we're all done with it. We're done. You can get the, I'm just gonna, return this error and I'm done with it. You can absolutely get that, but you have to understand how Rust is structured in order to make that happen, or how you do that idiomatically in Rust in order to make that happen. The advantage to the way Rust is doing it is you don't get a lot of try except or try finally boilerplate around your code wherever you're dealing with exceptions. And a big advantage is you can always tell from the interface of the function you're calling whether or not C++ programmers know exactly what I'm talking about here. You can always tell whether or not your function that you're calling is going to emit an error or not, because it's right there in the type signature. And you don't have to struggle with any except or no except or whatever the latest rules are in C++ about whether or not a function will emit an exception. So it's I think it's quite powerful. So let's jump in. Any questions before we get into sort of idiomatic error handling in Rust? Okay. So the first thing I'm going to do is I'm going to create a library, cargo new, and I'm going to make my library. Oh, yes, I certainly can. And cd mylib. So now I have an empty library called mylib, which I will edit in editor known as Rust Rover, IDE, I suppose, known as Rust Rover. I will try to make this one bigger as well. Control Command equals, holy mackerel. I don't have a scroll wheel on my mouse pad. I mean, on my trackpad. Maybe Command. Yeah. Yeah, I don't have this thing set up to do a command, command plus, command minus here. Yeah, I saw it here. View, zoom, tool, appearance, zoom IDE. Let's do, yeah, very primitive. Is that big enough? A little bigger? Okay. Okay. So here we have our library with the main.rs. That's weird. Well, cargo makes a bin by default. Sorry, guys. Let me start. Okay, that's much better. And I will set this up. So that I can now do a cargo test. And then, right. And you can see here that my default test here is working. Okay, so let's start with a problem. Let's say that we are building an application that is going to, or we're building a library that's going to, I don't know, add two numbers together, right? Something trivial. So we will create a function, odd, add, and so I'm going to create a module called add. And this add module will have a function called add. And in this, we will take two U8s just for fun. U8, B, U8. And add is going to return a U16. No, actually, add will return a U8. And of course, we will say A plus B. And that should build for us. I should have not called it add. Mod add. That's so strange. Okay, so if I do this and I want to export this publicly, I just don't. I want add in the public namespace, so it's pub use add, right? Say again. Yeah, pub. I could just do pub mod, but it's not what I was intending to do. I'm just trying to re-export the module. But that's strange. Okay, so I've just got a function here that's called add, and of course, if I write a test for this, what I can do is I can see that I'm going to get a 1 + 1. So I'll do a tmod. So here's where I'm going to put in my unit test. I'm going to use cargo add dev, and then there's an assert to crate that I like the way it does assertions. And here I'm going to say security. There we go. Here I'm going to say write my test function, and I'll say 1 + 1 gives 2. Okay, so I'm expecting a 2 back. Let A equal 1. Let B equal 1. And then I'm going to call my function. And then say, OK. So at this point, when I run my test, I've got one good working unit test. So far, so good? Now, everybody, I used U8s for a reason. You can probably guess why. Because I want to run into a problem here. We have a problem that our API isn't going to work when we get over 255. So we now have a fallible interface. In other words, add technically should be fallible. So if I write another test function here that says 1 + 255, okay, what should it give back? So ideally, any thoughts what it should give back? 0. Yes, that's one option. It should throw an error and panic, right? Saturate at 255. So 1 + 255 should still be 255. We've got a lot of choices. Yeah, so the comment was it will actually panic because we are going to be running in debug mode, and Rust will panic on overflow in debug mode, which is correct. Yeah, I saw one more hand. Right, other than 256. It'll reboot my computer. Okay, so that's actually an interesting point. In C, overflowing integers is undefined behavior. It is not undefined behavior in Rust. It's well-defined behavior. You will panic in debug mode, and you will wrap in release mode. Now, I think we've made progress. It is defined behavior. I would argue that is not the right behavior. 255 plus 1 is not 0. So, I don't think we're there yet, but at least it's not undefined behavior or UB. So what should it give? You heard a bunch of different answers, right? It should wrap, it should give it should error, it should panic. So I don't know. We had somebody introduce themselves here as writing code that runs in a spaceship. How do you feel about panicking when you have an unexpected value come out of your inertial guidance unit? Yeah. You really want it to panic during development, but at the end of the day, how do you feel about? Well, I'll tell you how I feel about it. Some of you have seen this before. Delta 4. Oh no, not. Is the Ariane 5? Yeah. All right. So this is the maiden launch. This is the maiden launch of the Ariane 5 rocket. It's a European Space Agency rocket. And the Ariane 5 launched, and it had some fun going up. It was doing really well until it decided it needed to change direction. It was going the wrong way to space. Spaces must be down. And so it started to turn at about 49 seconds. And of course, if you're hypersonic, that doesn't do well with your airframe. That's a wrap, by the way. This was an F-16 that overflowed and wrapped. So it went from up to down. Okay. Okay. And there's a super tragic story here. I mean, not like somebody died. Yeah, look at this guy, right? He's probably the guy who wrote that code. I won't get into we won't have time to get into the story. We can talk about the actual story behind this afterward, but it's really remarkable how this situation occurred, and the system that turned the rocket around wasn't even needed for this rocket. But anyway, so it's important to get this stuff right. And I think the right answer is to return an error. Now, I'm going to do the addition. My job, right, on the label, I say add. That's what I do. So my job is to add. And if I can't do it, I got to let you know. What you're going to do about the fact that adding doesn't work with the numbers you gave me is up to you. The policy is not in the add function. The policy is in the caller of the add function as to what to do about it. The caller could panic. The caller could wrap. The caller could do whatever they want. But the adds function's job is to add if it can. So we should say returns an error. And that's probably no surprise given the nature of today's talk. So the expected result is error. We're going to get some kind of an error, but what does that even mean? Well, maybe the first thing we should think about is what should our error look like? So let's pause for a second. I'm just going to leave that so it would still compile. Let's pause for a second and let's talk about errors. So I'm going to make an error module. And in this error module, I'm going to do a couple of things. For time purposes, there's a bunch of boilerplate we could write. I'll do pub error. And then there's going to be an error type. Maybe we're going to have an overflow error. We've just defined an error type that's going to return an overflow when we ask it to. So we can go back to our unit tests, and we can now say we're going to get back error overflow. That's what we're expecting to get back. we will go ahead, make the call. And we're seeing a problem already. Anybody, any of the beginners want to see why this is giving me a red squiggle? Okay. It's the wrong type. So this is where the type system gets involved. We're not using a sentinel value like a -1, which wouldn't make any sense in an unsigned value anyway. We're not using a sentinel value. We use a different type. So I'm actually comparing a U8 with a result, which is a different type. So the compiler won't even compile. It says that doesn't make any sense, and we'll get an error that you can't compare these two types. So that's fine. We're gonna change the type signature for add, and we're gonna give back a result of U8. So what's gonna happen is if result is successful, you're gonna get a U8 back. I'm sorry. If add is successful, you're going to get a U8 back. If add is unsuccessful, you are going to get an error back. And this error will be the error type, which we have created here, or which we've imported there. So now we've got this fallible interface, and the interface is going to be adding a plus b, but returning a U8. But we need to return a result, so the types don't match again. So let's try how we want to return this result. Any ideas? Am I looking for the correct way to do this or the naive way to do this? No, the correct way is fine. Or you could use the standard library. Okay, so the response was the correct way to do this would be to expand both of these types to U16 to check to make sure that their sum doesn't overflow 255. Then you could return a result, or you could use a standard library function, checked add, to do that. So I think that's great. Let's do checked add. So a dot checked add b. And what this is going to do is it's going to add a to b, or add b to a technically. And if that overflows, we're going to get nothing back, get a none type back. So we need to convert that to an error. So we now have, so either we're going to get, if I can split this line up a little bit, you can see that checked add returns an option of U8. You're either going to get none, which means there's nothing here, or you're going to get some with a payload of data of U8. And because we're dealing with errors here, we're going to convert that to a result, where the result is either going to be OK U8, which is what this would represent, or we're going to be, we'll have an error over here. And now, oh, okay. I probably shouldn't do it this way because Rust doesn't let me, well, yeah. S dot is okay. Well, let's do it quickly. Let assert okay sum and did I get that right? Thank you. And then I will say assert res equal expected sum And this will be, I guess that doesn't matter what the sum, because if we know this is going to, did I do this in the wrong test? I meant to do this in the overflowing test. Okay, I'm just gonna leave that alone because that's still correct. But here we're gonna do this here. I guess we'd have to do it in both places. So I'm gonna do let assert. Okay, and then I'm going to, and then we don't need to do an assert on the sum because I am expecting an error. Thank you. Error overflow. So I don't need to do that. I'll go back to assert. Now my errors are not comparable, so I have to do let assert err error overflow equals res. Okay, thank you. Okay, so now we're asserting that we're getting this particular error back out of result. And of course, this is not needed. Now this should be okay. And you can see now that we have two passing tests. So moving into the error hierarchy, what's happening here is that we've just defined one kind of error. If we expand this and we can say, okay, well, maybe we're doing advanced types of math and we'd like to sort of talk about addition overflows or floating point precision errors or other types of error, we can build what's called a hierarchy of errors. So what that looks like going to use a crate called this error, which will get rid of quite a bit of boilerplate. So for me to define an error, I'm going to define every error as implementing the error trait. And then I'm going to say, you know what? There's going to be an overflow error. Here's how I'm going to display it. Error is going to be okay. So what I'm doing now is I've containerized overflow errors. We're going to maybe have rounding errors and other types of errors, but I don't have the original error type. I'm going to do one more thing here. I'm going to create a module called overflow, where I'm going to put all of the different kinds of overflow errors that I might run into. In this case, there might only be one, which is where we started. But if I back up, I now have this category. You might say, well, why would I do that? Well, maybe overflow is maybe it's not a good case because there's only one way to go. But I don't know what to call it. Positive overflow, max overflow, I'll say. And then there's another kind of overflow, which some people call underflow, but it's not underflow, is when the number is too small. Okay, so if it goes below 0, that's also overflow. Underflow is something completely different. We might have other cases where you might want to capture your A and your B. You can put the payloads in here as part of your error types if you wish. You might have cases where you're handling values that maybe are illegal in your range. So you're going to say invalid range, maybe for the purposes of whatever your errors are doing or whatever your values are doing, you have to have something between 100 and 150. And you've added something up that says 37. It's a perfectly valid U8, but not useful semantically. All of these would have explanations on them. Error. Okay. So these are the messages that would print out on the screen if you ended up with one of these errors being emitted. All right. So now what we've got is this hierarchy. We then have a second hierarchy. Maybe we're parsing arguments, as we saw from the previous demo in our application. So okay. And we can follow the same pattern. And what's nice about this pattern is there is a high degree of similarity between the various different error types that we're defining. Yes. Yep. That's a great question. So the question was, there's another way to handle errors in Rust using something called box-dine error. Box-dine error. And this is a form of what's known as type erasure. So what that means is that the actual error type that you're storing as a dine error, as a dynamic error, you don't know what that is anymore. All you know about it is whatever error type you have, it implements the error trait. So there are cases in which if you don't care what error type you're getting back, all I'm going to do, my policy is always just to pass it along and eventually get it out to the user, and I'm going to quit, basically the equivalent of a panic. Then there's actually libraries for that. There's a library by the same author of this error called Anyhow, which does a fantastic job of allowing you to do that. It also allows you to provide context to the error. I was opening this config file for this reason and it wasn't found, or these permissions weren't set. You can add all of that context to the very simple OS error that you get, such that when you're debugging a large application, you can figure out sort of what happened. The difference here is that you're providing a library. In this case, we're providing a library for users of our library. And when I put this out to the world, I don't know whether my users care about some of my error types or not. Again, I don't want to impose my policy on all of my users. So by giving them the information that they need to make the best possible decision, I'm giving them a very granular error type. If they choose to recover, if they choose to retry, if they choose to message the user based on certain criteria, or quit based on the error, they are free to make that choice when they adopt my library. So that's often what you'll hear in the Rust ecosystem is, detailed error hierarchy for libraries, and dine error sort of all in one, who knows what kind of error it is, it doesn't matter for applications. I think that's pretty good advice for starting out, but in general, once you get the hang of this, it's actually not hard to always give out really good errors, and you never know when you actually do care about the error type. The Yeah, the question is, what should you do if you know your library is going to be opening up a file and you might get a file error? Should you wrap it up, or should you in a bespoke error type, or should you wrap it up in a Dyn error type? What should you do? Is that Well, it depends on what policy you want to inject into your library. In general, I find it more pleasant to use libraries that don't force me into their way of thinking, because I might be thinking differently. If they're not enforcing a policy on me, then I can use it however I need to in my circumstance. So I tend to prefer giving the user the choice, but that is not free, because you can always just say, here, take my error, and you don't know anything about it. If the error I'm wrapping in my bespoke error type is from the standard library, I am completely open to exposing that to my users. If the error that I'm exposing comes from one of my dependencies, who is not the standard library, we get into the exact problem. Why can't I find you? It's crazy. I'm like, that Chris was talking about. I know, you're right there in front of me. Okay. We get into the exact same problem that Chris was talking about earlier, where I am exposing the error API from your library in my library. And if you change your error API, guess what? All my users are broken. So in the case where I do not want to create a transitive dependency, it actually is really important to go to Dyn error to say, look, this is some kind of error type, not standard library, because everybody generally will have a dependency on the standard library. But the Dyn error type would allow you to erase the details, and now the dependency that you're relying on is no longer being leaked to your users. So it's a very important consideration with Semver and your API. Tricky stuff. Okay, so where was I going to go with this? Oh, yes, I was creating some argument error. So in, maybe missing arg. Okay. And you could imagine a list of arguments, a list of errors going on in these types that go on, forever. Now, what we end up with here is this hierarchy. My library, my lib, will emit a mylib : error. That's the type you'll get out of it. Everything that you could get, every error that you can get out of my library is contained within that enum. It may be nested, but it's all there. So that's often really nice, because even though I'm being super detailed, my users can handle one type. And if they care about some particular subtype, they can sort of drill down and special case that one. But there are cases in which you don't necessarily want to roll up every error under one root error type. Sometimes you might want to be able to export two different error types. There's two completely different domains, perhaps, in your library. This doesn't prevent that, simply not including it here. So like if I am not including my invalid argument error, now this module still defines an error that if I export, at the root, and I don't know why exporting wasn't working earlier, but if I export it at the root, this is why I wanted to do it. Let's do this. Pub error use. Okay, so that's me exporting the root error type. Pub use error. Maybe add was just colliding with something. Okay. So now, as far as users of my crate are concerned, there are two distinct error types that you can get out of this crate. You can get an error, a mylib : error. You can get a mylib : argument error. And so you don't have to unify everything under one root. if you don't want to. Now, the final thing, just for time, there's a lot of other things I would be interested in showing you, but we're running short on time here. Is the result alias. So a lot of times when you're using errors, you have to specify both what you get in the OK sense and what you get in the error case. So you can make this a lot easier on your users by aliasing the result type from the standard library. So you can say here, hub type result. Okay. Okay, so it's like, whoa, what the heck is all that? So what I've just done here is I've created an alias for the result type. That alias says that result, whenever anybody uses the result that I'm defining here, and I'll show you how to do that right now. Okay. Now this result is not the standard library's result. It's the one that I just defined in my error module. So for this one, I no longer need to specify what error I'm going to return, because this defines that by default right here. And that is a usability win, because now the user of your error type can simply think about what data they want to return. The right thing happens with the error, as long as they're importing the result from the very same error scope that they're importing the error from. So I'll do the same thing here. And so when I copy paste the each of these error hierarchies, they come with the this result. And so suddenly the error, using these errors as a user, I don't have time to show you sort of what it would look like from an application, becomes very ergonomic with that result. So any questions about any of this so far? Yeah. The question is, or the comment is, it looks like you prefer to just use the name error and not preface it with the package name or the module name that it's being stored under. I do. It is a preference. You can do it other ways, and that's also fine. I prefer not to have redundancy in my hierarchy. So when I'm looking through my code, I see error, and I can see argument, and then error. And I know that that is the argument error type that I've defined, rather than argument, and then this says argument error or something like that here. What that allows me to do is to import the namespace, which is what I've done here. Okay, I could just as easily say argument error result. And now all my code is using the argument subhierarchy. I haven't changed any of my code. Now it's not going to run because I don't have an overflow in the argument subhierarchy, but that gives me the flexibility to be able to return exactly the kind of error that I want. Correct. And you saw me do that for the user of my library. I don't want the user of my library to have to worry about how I organized my tree. So I'm re-exporting argument error as argument error right up at the top of my hierarchy. So they would use mylib : argument error. Yes. Yep. Yeah, so if they were importing my library, the comment was they can also rename it and import it as they see fit. Okay, so we are at time. Sorry, I had to rush this a little bit, but there's a lot more to how Rust does argument or does error handling. I didn't get into the try operator and some other goodness, but maybe I'll do a part 2 for you guys to see how we actually use it to make it idiomatic. Okay, thank you.